Welcome to Calculus. We're going to look at sequences today. This is actually one of my favorite topics within the calculus continuum, if you will. And sequences in the next part of this would be series and the different things we can do with this, because there's lots of really neat stuff that goes on with these two pieces. Some people struggle with these topics, but if you take this from the approach of not trying to dig overly into it, but at the same time trying to understand it quite well, which is a fun little balance to maintain, you'll find that it does go fairly decently. Okay, so the idea of a sequence is a collection. So the biggest piece of that to remember is that when we talk about a sequence, we're simply talking about a collection of objects. Now, in this particular event, or this particular setting, you could also replace the word object with elements, right? In our case, we're going to almost exclusively be dealing with numbers. So a collection of objects, elements, or numbers that have some type of common characteristic. Now, in this particular instance, the common characteristics with these numbers is they are going to follow a rule. They all have the same rule, which we will refer to as a expression. All right. And when we say an expression, we're talking about some type of just basic value of some sort that allows us to be able to figure the piece out. A lot of times this is written as an equation, which just simply means we have an equal sign in there, but it might be something as simple as, say, 1 over n. This would be the rule. This is the expression. And a lot of times we'd say that n equals that, and we're assigning a sub n as the having the value of 1 over n. Now, how does this work? For this particular sequence here, we can build the sequence. We'd say n equals 1, which just simply means plug in 1. So a sub 1 would be equal to 1 over 1, which is 1, right? Then we can say, well, n equals 2, which means we're dealing with a sub 2. So we have 1 over 2. N equal to 3, which means that a sub 3 is equal to 1 over 3, right? And we just keep on going. So n equal to, if we jump down a little bit, n equal to 10 means that we're dealing with a sub 10, which is 1 over 10. Now, I picked this one as being the first one we're going to look at for a number of reasons, one of which is this particular sequence is actually what we call decaying here. It's getting smaller. It's approaching a value. So in this instance, this particular sequence is what we're doing, or what it's doing is it is converging to a particular value. Oops, not E there, huh? It's converge, okay? This one converges to 0. Now the next piece of what we're going to talk about in another video is going to be sequence, or is a series. And just because the sequence itself converges doesn't mean the series is going to converge, and we'll look at the difference between those two events there. But the series, or the sequence here, converges because we're essentially dealing with a limit. The limit as n goes off to infinity of 1 over n. In this particular instance would be 1 over infinity if you were to plug it straight in. And if you remember, this is an indeterminate case, which means that we can't just write down 1 over infinity. So we could use L'Hopital's rule, although that's overkill, because 1 over infinity over 1 over a very large number means that this is going to 0, which is the definition of converges to 0, or to converge to any value. In this instance, it converges to 0. So the limit goes to 0. If we had the limit going to 12, then this would converge to 12, which has some pretty good or useful implications for us. Now, there are lots of different types of series or sequences. One of the things we want to look at is what are these other types that we can deal with. So let's just say that we have other types that we want to look at. One of which we can call, say, something like this. Let's just say that we have -1, and then we have +2, and then -4, and then +8. And then we just keep on going and going, right? It goes on forever. Does this converge? There are two big pieces that are happening here with this thing. One of which is that it's alternating between positive and negatives. So this would be what we'd call an alternating sequence, okay? Because it quite literally changes sign. It alternates signs from -1 to 2 to -4 to 8, and it would continue that trend, okay? So how, if we want to write out the rule or the expression that would define this process, what would that look like? Well, it would start with saying you have some negative raised to some power here, where my first term here is 1 or -1, however I want to write this. And in this instance, we're probably going to end up having some type of power here, which is going to be defined as having this. Now, if you look at this, this is always multiplying by 2. So what if we just say times 2, all right? Well, that doesn't give us the first term of 1 that we need. Well, how else can we do that? What if we do -1 here, right? So if we do -1, and n equal to 1 would give us our first term. That's 1 minus 1, which is 0. 0 times -2 to the 0 power is 1. It still doesn't work, so let's put a negative right there. All right, now does it work? Yeah, that'll give us the first term. What about the second term? So n equal to 2. So this is n equal to 1. This would be n equal to 2. So you plug 2 in. 2 minus 1 would be 1. -2 to the first power gives you -2 times -1 gives you +2. Check the third one. So that'd be n equal to 3 right here. So 3 minus 1 would be 2. 2 raised to the second power would be 4. Times -1 gives us -4. So that works. That actually does get us all of them. Now, one thing I do want to point out here is that I'm starting when n equal to 1. That's kind of our standard notation. If you'd let n equal to 0 being the first piece there, then it would change. Instead of n being a sub 1, it'd be a sub 0, right? And -1 to the -2 power to the n is now what we'd be dealing with. And this works as well. There's nothing wrong with writing it this way. It's just another way of writing it. These are both equally correct. So I just wanted to make sure that you are aware of those different ways that you can write this. Typically, though, we're going to start all sequences with n equal to 1, which is why I did this one over here first. This is going to be the one that we're going to use the most. So don't worry too much about doing it this alternate way, but do be aware that you can write it in alternate ways. Also, another piece to think about with this one is this is kind of a geometric series, if you will, a geometric sequence rather, since we're still dealing with sequences here, in that it has the behavior. If you were talking about this being a function, it'd be an exponential function because the variable is in the exponent here, right? So this base right here actually tells us a lot. Does this particular sequence converge? No, it just keeps getting bigger and bigger. So in this case, the limit as n goes to infinity of -1 times 2 raised to the n minus 1 power is equal to infinity. There is no limit. All right, is another way you could say that. So this does not converge. I forgot my word, does not converge. Now, what does that mean? Well, it has a lot of implications when we start getting into series, which is really the big piece that we want to talk about. We need to get our heads wrapped around what a sequence is first before we start getting into series. But we have alternating series that we've talked about, and then we've also have geometric things, and then these come in lots of other forms as well, including a arithmetic sequence, and we have these common ratios that we can work with, and also other things that kind of fit all together. Be used to trying to graph these. And another big piece I do want to point out is that this right here, this sequence is what we call discrete. And when we say it's discrete, it means it's not continuous. That's really all it means, is not continuous. So sequences in general are not continuous, okay? They are just, this is true about all sequences. They are all discrete, which means that we're letting n equal 1, equal 2, n equal 3, and we don't have any values in between this. If this were a function, these would be different points on the line, but there'd be points in between them. Here, with it being a sequence, there's nothing in between n equal to 1 and n equal to 2. That is all the values right there. -1 to 2, it jumps from one to the other, which means that this there aren't we can't talk about this being a function, which means that we can do other things with it, or we have to do other things with it, which is kind of interesting, and we're going to get into those. I hope this is useful. I hope you continue to dig in on math and look at all the different neat stuff that exists within the world of mathematics. Calculus especially is a lot of fun. If you need more explanation or different explanation, just let me know, reach out, and keep doing math. Take care.